So when the garbage collector collects objects in the young generation, this is called a minor garbage collection. And what happens is this. Objects are allocated initially into the Eden space. When the garbage collector runs, objects are copied into this survivor space. It's copied into the empty survivor space. Objects from the survivor space that was used during the last garbage collect also get copied back across into this new survivor space. And the survivor spaces are now swapped. So the next time a garbage collection runs, what was the old survivor space is now the new survivor space, and that will be used to do the copying. The next allocation will then get allocated into the Eden space. So it looks something like this. Here we have some root references to objects that are both in Eden space and in the survivor space. The initial survivor space is called the from space. At this point, somebody has tried to allocate some memory. We try and allocate that object into the Eden space. Eden space is full, so we'll kick off a minor garbage collection. What happens now is we walk the heap, we mark the objects, and then we copy the objects into the new survivor space. The figures on these objects, 0 and 1 here, show how many garbage collects these objects have previously survived. So the object in the survivor space has previously survived 1 garbage collection, whereas the newly allocated objects in the Eden space survived 0 garbage collections. But we'll see that as we copy them to the 2 space, this number increases. We go from 0 to 1 for each of these objects, and then we move the object from the survivor space into this new survivor space. Its count gets increased to 2. And then finally, the Eden space is cleared and the survivor spaces are swapped. And the next allocation happens into the Eden space with now a count of 0, i.e. this thing hasn't yet survived a garbage collection. So a minor collection happens when the young generation is full. When the old generation is full, then a major garbage collection happens. Now major garbage collections are going to be slower than minor garbage collections, as a major garbage collection is going to walk through a large section of the heap. It's also possible that memory that's been allocated has been paged, so that memory has to be paged back in. So we'd like these major garbage collections to run less frequently than the minor garbage collections. So a major garbage collection is triggered when the old generation or the tenured space is full. It will typically, on the Oracle Java VM, collect both the old and the young generations at the same time. Although this is really called a full GC. A major GC collects the old generation, a full GC collects the young and the old generations at the same time. But the terms tend to be used interchangeably. So with a major garbage collect, memory gets copied from the young generation to the old generation. So this is called promotion. So the JVM will eventually promote memory into the old generation. This happens after the memory has survived a certain number of garbage collects. It also happens if survivor space is full. If the survivor space is full, there's nowhere for objects that have survived a garbage collect from the Eden space to go into that survivor space. So we'll start promoting from the survivor space into the old generation. There's also a flag you can pass to the JVM to say always tenor, i.e. always create objects inside the old generation. So it works something like this. So here we have a similar picture to before. We have a number of objects in the Eden space that have yet to survive a garbage collect. We have a large object in the old generation with a collection count of 9 that survived 9 garbage collections. And we have an object in the survivor space that has survived 8 garbage collections. When we run the GC, we'll notice that the objects from the Eden space get copied to the 2 space, and the object that was in the survivor space has now survived many garbage collections and so is promoted to be part of the old generation. As well as objects being moved to the old generation once they've survived a number of garbage collects, it's also possible to allocate objects directly into the old space. Now, there's no direct way of doing this. There's no JVM option to say always allocate objects in the old space. But what you can do is set this option on the VM called pre-tenure size threshold. And then objects larger than n bytes will be allocated into this old space directly.